really want to emphasize that you don't have to really strictly follow all of these rules. Especially if you're on the app side of things, you can be a lot more flexible about it. But if you're building libraries, internal or external, or like something really core that a lot of others are going to use, then please take a good look at these guidelines and try to follow them so that we can all have a nice time in Compose and have common understanding and expectations of how these components should work. I also don't expect you to remember all of these things after the talk. So again, the guideline docs are always there. You can reference them if you have a specific design problem. But if you took a couple ideas away from this talk, then I'm already happy with that. All right. Hey, everyone. Thank you for choosing this talk. Again, it's lovely being here. My name is Marton Brown. I'm a developer advocate at JetBrains, working on things like Kotlin Multiplatform. Come find me with questions later. And I just want to very quickly highlight that it's the Friday the 13th, which is just an excellent date to be speaking on. It's no secret that I'm passionate about API design. I've given a couple of talks about it in the past, and I've written some things about it as well. And this is because I really do believe that everyone is an API designer. Regardless of what kind of development you do, whether you're building like frameworks, libraries, or just app code, you are designing APIs. Like, again, even if you're building an application, you're building APIs for your teammates to use. Even if you're a solo developer, you're going to be using your own APIs later on where you have forgotten the times when you wrote them. So it's important to think about how you build APIs. Of course, the importance is a scale here. So it's a lot more important if you're writing some kind of core code that a lot of developers are going to be calling, and you can be a lot more flexible about it if you're more on the app side of the scale. So this talk is going to cover these two documents which live on GitHub. These are by Google, and they describe API guidelines for Jetpack Compose and API guidelines for composable components in Jetpack Compose. There's a bunch of overlap between these. And they are very, very long documents. It's about 13,000 words. Some online tools estimated that it's about an hour or two to read all of this. And it's dense technical writing, so I hope to bring some of the highlights of this to you in this talk. The idea behind these guidelines is to have some kind of common understanding of what idiomatic Compose APIs look like. And then hopefully all of us will be building APIs with this common understanding in mind, which means that if you have some practice with like the built-in things from Foundation or Material or some of the popular libraries, then your skills are transferable, because as you start using some new composable components, they will behave similarly to how you've already used other composable components if you're designing them the same way. So these documents do say Jetpack Compose on them, which is an excellent Android library. But I really do have to highlight that if you learn these things about Jetpack Compose API design, you can actually reuse all of that with Compose Multiplatform, which if you haven't missed this morning's excellent keynote, you already know about. But it's a way of bringing the same APIs to not just Android, but also iOS, desktop, and the web. And this is the current state of support for Compose Multiplatform. So iOS is currently in alpha. Android and desktop are stable. You can already build Windows, macOS, Linux apps if you want. JetBrains Toolbox is a great example of this. And web is currently experimental, but maybe hack around with it and give us feedback. A very quick overview of what we're going to cover. So we're going to look at naming first, start with some simple things. Then we'll explore a bunch of things around the parameters of components. And finally, we'll take a look at a couple things around state handling. This is going to be a lot of code, so I hope you've had your coffee, and we'll get started. So naming first, starting with something simple. This is how constants are supposed to look like in Kotlin. This is what the Kotlin style guide tells us to use. It's the same like shouting convention that Java has for static constants. And Compose actually doesn't use this convention. Instead, Compose chooses to use camel case for constants with an uppercase letter up front, which goes against the guidelines. But the idea for Compose is that they don't just use this for constant properties like this. They also use it for other properties, which are basically constants. They are just not primitives, so they can't use the const keyword. And they also use the same naming convention for objects, whether they're top level or maybe inside a sealed class or some other class. And they also use the same convention for enums. In all of these cases, the things that have the same naming convention are semantically the same. They are a constant value. You can safely reference them. It's stable over time. And whether it's a property or an object or whatever else is really just an implementation detail. So according to the Compose guidelines, you don't have to care about this. All of these should be named the same way. So that was easy. What about functions? Can anyone in the audience care to shout how composable functions are supposed to be named? I heard uppercase. And any other takers? Who agrees with uppercase? Let's do that. First letter uppercase. Okay. So of course the answer is that it depends, as everything. So there are two categories of composable functions. We can sort every composable function, hopefully, into one of these categories. They can either emit content or they can return a value. And never the two shall meet. So you should not have a composable function that does both of these things. Let's take a look at some examples. So for emitting content, here are the composable functions that you probably use a lot if you're writing Compose. So things like button and column, these emit UI specifically, so it's clear that they emit content. And we have this uppercase naming convention for them to indicate that when this function is called as part of the composition, it is creating a thing. When this function is called, something will exist as a result of calling it. So these functions kind of look like constructors with this uppercase naming. And this doesn't just have to be a UI, of course. So we also have launched effect and similar functions, which are also a thing that will exist in the composition. It's an entity of sorts. So we also use the same uppercase naming for these. And it's important that the names of these should be nouns. So it shouldn't be like, create button or something like that. We just we just call button, and that will manifest the button for us. So in the other category are composable functions that return a value. The purpose of these is not to emit something into the composition. They don't produce UI, for example. Instead, they return a value, and they do that having awareness of the context of Compose. So they might access composition locals to produce that value. They might rely on composable state and produce new values as state changes, but their primary purpose is to return a value. And examining these functions that do return a value, it's important that you should not follow the special case that Kotlin has in its style guidelines, where you can create these factory functions which mimic constructors by just having the same name as the type that they're returning. If this is a composable function, you should not use this guideline. Again, you should stick to the lowercase naming to indicate that this is going to be a composable which just yields a value. And this especially applies if it's doing something more complicated. For example, you can have these functions that already remember the value for the caller. So on the call site, in order for you to know that you don't have to remember that value, you should use the remember prefix, and you should, again, keep to lowercase. All right, there are a bunch of things which these guidelines define, rather a lot of different terms. I'm going to condense some of those into a single one, which I'm going to call component. So a component is going to be a composable function that returns unit and emits exactly one compose UI tree node. Returns unit, emits a node into the UI tree. We're going to look at these in turn, starting with why a component should emit exactly one node. So we have a bunch of basic Compose code here, and when we're building Compose, we're always thinking in trees. These function calls always have a tree structure. So in this case, for example, we could represent this using this tree here, where we have the root up top, which is the column, and then that has three children, the text, and row, and so on for the rest of the nodes, with those texts nested in the buttons at the very bottom of the tree. And the very cool thing about Compose is all the code that you're writing is just Kotlin code. So things like extracting a function work really well. So we can just take a look at a bit of Compose code, like that piece right there, and we can extract it to a separate function. For example, I'll extract those two text nodes and call this function title, and then where those used to be, I can just call the title function, and I'll have the same behavior as I had previously. You can also do this with intention actions in the IDE in an automated way. But if we look at the tree that we've generated down here, it's rather odd because it doesn't have a root anymore. So this title component doesn't produce a single UI tree node. It produces two different nodes, which in the example above will be attached to the column that we called the title component in. But this is a dependency of this component because it can only be called when you are inside a column. And a healthy Compose component should be like self-sufficient. It shouldn't depend on the specific context where it's being called. This is a great way to produce bugs like this, where if you don't call this in a column, but you're in some other layout like a box or wherever you are, then you can really easily end up laying out these texts on top of each other. So in order to not have the chance to make this mistake, this component should, again, emit just a single root node, which we can fix in this case by just creating a column within the component, wrapping the text with that. And in that case, we have like a proper tree with a single root, and this can be used anywhere we want to. I hope you also got the subliminal message on that previous slide. Getting back to the definition, the next thing I want to take a look at is why these components should return unit. So why it is that whenever we have functions that produce UI, they should not also return something. There are a couple of reasons. Here's a bad example, which you should not follow, where we have an input field composable. We can imagine that that displays something on the UI, and it returns an input state object, which contains whatever the current input is, like as a string or something like that. And then we have this example code, which creates an input field, receives that state, and then passes it on to a button listener so that the state can be cleared when we press that button. I'll highlight just two of the major issues here. One of them is the ownership of this state. So the input field has created that state object for us, and then it returned it, which means that it has full access to that state. It can modify that state at any time. But on the call side, we also have full access to that state. So the component is stateful. It already contains its own state and can modify it, but we can also modify it. And these two sides don't know if the other one is doing anything with the state. So this problem of shared ownership is the first problem. And then the other one is a bit more simple. This restricts us to only referencing this state after we've already called this function, which is really inconvenient, because what if we just want to reorder our UI and have the button up top? Now we no longer have access to that input state because it will only be created when the other piece of UI exists. So in order to fix this, we would be much better off with a stateless component like this, where instead of creating the state, it receives the state as a parameter. This way, it's controllable externally. Whoever is on the call side is free to create that state any way they want, and then they can pass that into the component to control it. And of course, we also don't have the ordering issue at this point, because now we can just declare the state anywhere in the tree and then pass it on to any of the components that need to reference it. So this is how composable components should be driven. They should ideally be stateless whenever you can manage it, so that they can be controllable externally. And their purpose is this very classic thing. If you've ever seen a Compose talk, you've probably seen this already. But they have to take their inputs, the data that they receive, and turn it into the UI. And so up next, let's talk about those inputs. The primary way of providing inputs to a composable is through the parameters, as we've already seen. But I actually want to take a side note here and talk about composition local a bit. I will not show all of the syntax of how to use composition local. If you want to learn more about it, you can follow this link. And as with all links, these are going to be on the final slide, so you don't have to take a picture of each link along the way. So composition local is a mechanism where within your compose tree, at some point you can provide a value for the rest of the subtree that node is in. So for example, we could provide some value there, and then everything that's below that point in the tree would have access to that value in this ambient way, if you want to say. So for example, in that node over there, we could reach out and grab a value that has been provided as a composition local without having an explicit parameter for it. Now, this has its use cases. Mostly, you should use this for styling, which is really like a global concern, and it's really convenient if you can change that at the app level or at the screen level, for example. But you should really not use this just to pass data down. Like if you've extracted something from an API and you have like data to put on the screen, please do not use composition locals to pass that down. Please prefer using parameters instead, which is Compose's general attitude. So you should prefer explicit parameters over the implicit composition locals and really only use that essentially for just styling purposes. Another thing that Compose is huge on is using default arguments. Default arguments are great because we can have these really complex composables that offer a lot of customization with all of their parameters, but they can be callable with just the required arguments. So in the case of text, for example, you can just pass in a single string and you already get a working piece of text on the screen, and then you can go on to provide more of the optional parameters. We can also see a great example in the text composable of using composition locals. It's a really nice way of going about it to grab a composition local as a default value for one of your parameters, because that way your component can pick up the composition value, the composition local value by default, but callers can always choose to override it if they prefer to do something else as a local decision. Something you should not be doing is using null values to mark that a value has not been provided. So default arguments for composable components should be real values whenever possible. And if you use null, then null should really indicate the absence of value. It should mean that something should not be set. But in this case, in this example here, we're using it to indicate that we should fall back on some default value, and we could have just placed that default value in the signature in the first place. Here's a nice example of using null. So the button composable uses null as the default value for the border of the button. And here null really means the absence of value, in that if we don't provide a value, then the button is just not going to have a border on it. Something else that we can take a look at in this same signature is that if you have a lot of default values that you provide, it's a nice idea to collect them into a single object with the convention that it should be component name defaults. So you're using the defaults suffix for this object. In the case of button, we can find this object. This is a very, very shortened version of it. But as you can see, it provides a bunch of things like the default sizing information, as well as functions, for example, to produce some of these button-related types like button colors and so on. And if you make this accessible to users, then they can actually reference these default values. So imagine a case where in some situations, based on some kind of condition, you have custom colors that you can provide to the button, but in other cases, you want to fall back on the default one. If these defaults are nicely organized and made public, then on the call site, we can use them in conditional logic and sometimes use our own things and sometimes use those built-in default values. But if you were to decrease the visibility, for example, make these default values internal or private, then you would take away this ability from the users of your components. All right, next up I want to talk a bit about modifiers, which are an excellent part of Compose's API design, at least in my opinion. So modifiers give us this ability to only accept a single parameter in our function instead of having to add like dozens of parameters for customization of size and padding and background colors and cropping and all of these things. We don't have to add all of these separate things to the signatures of our components. Instead, we can just have a single modifier parameter, and then we have this nice chaining API where we can customize a bunch of things in a single place. This also means that if you're providing a modifier parameter, you should not provide conflicting things as your parameters on the component. So for example, if you have a modifier parameter already, it doesn't make sense to also have a padding parameter because that can already be covered by using modifiers. An interesting question is whether you should have modifier parameters or not. Let's examine what happens if you don't provide a modifier parameter. You might think that that means that your component will not be customizable, but that's actually not the case because your component can always just be wrapped by something else which can accept a modifier parameter. And this essentially achieves the exact same thing as if you just had a modifier parameter in the first place and the modifiers could have been passed to your component. It just makes the call site really inconvenient and it introduces extra nodes in the tree. So in general, your components should have modifiers. This is going to be one of the first rules that we can extract from these guidelines, that composable components should accept a modifier parameter. Something great that I heard yesterday in a conversation, and I'm going to look certainly at the person who came up with this, is that if your component is a public component, so if it's not like private in a file, then you should provide a modifier. This is not part of the guidelines, but I think it's a really good way to go about it. If you have something that's only used locally, like it's just private in a file, then maybe it's fine to drop it, but really you should accept modifiers. Going on, this should be named modifier by default. It should be the first optional parameter. It should be applied to the root node of your component, and its default value should be modifier. We're going to take a look at all of these in turn. The first two are fairly obvious. This third one we're going to get back to, and I want to look at why it should be applied to the root node. So the idea behind modifiers is that whoever's calling into your component wants to customize that component. And if you have a component like this one, for example, then looking at your component from the outside, it essentially looks like a column, right? Like, because that's the root node that you're producing, so your component behaves like a column. So whenever you take a modifier as a parameter, then it should be applied to the column. A counterexample would be this. So if you were to apply that modifier to just part of your hierarchy and not to the root inside your component, then if someone wants to change something like the background color for your component, it would only change it partially. So these are the reasons why you should always apply it to the root node. Now, it's important to see that sometimes this root node in your component is dynamic. So, for example, you might have some condition, and in some cases have a column layout, in other cases have a row layout or something like that. In these cases, you should make sure that the modifier ends up being applied to whatever is the root node after all of these conditions are evaluated. So here you can see that in both conditions, the component that's emitted as the root here into the composition will receive the modifier parameter. It's also important that you only apply the modifier once, because you should have just one root, as we've already discussed, and you should not take multiple modifier parameters. If you find yourself doing that, then you probably need to change up the design of your component, maybe split it into multiple components or something like that. And then finally, the last thing we had here was that it should have a default value of modifier. In case you haven't looked into this yet, this default modifier value that we use is actually referencing the companion object of the modifier type. So modifier is an interface, there's a companion object in there, and that companion implements the interface. So if you just write down the type name, you get the companion, which is already an implementation of modifier, and it's an empty implementation of modifier, which means that if you use this as a default value and apply it to your root, and the callers have not provided anything to override it, then it will just have no effect at all. And if they did provide some values, then those would take effect on your component. Now, as you're applying this modifier, you're allowed to add additional modifiers onto it, but it's really important that you can only do that, you should only do that by chaining things on top of, like chaining things after the original modifier, like you can see on this slide. So something you should not do is this, to create a bunch of things with modifiers and then chain the modifier parameters somewhere along the way, like to the end or to the middle of that chain. So always put the modifier at the beginning of the chain if you need to add additional things. This is important because modifier order matters. I'm not going to explain modifier ordering here, but you can go to the docs on modifiers, which do that very nicely. Again, links are going to be at the end of the talk. Okay, next up, I want to talk about slots. I think I like slots even more than modifiers. They're an excellent piece of Compose, and they alleviate a lot of problems that you can have with the view system. So slots in Compose are this idea that we can pass in UI as parameters because we can express this as a type in Kotlin's type system by using a composable function type such as this one. So, for example, if you're designing a button and you want to offer customization to the callers so that sometimes they can put text on it or sometimes they can put icons in it or an image or whatever else or all of these things at the same time, then you don't have to try to create all of these overloads of your text function, your button function to accept these things. You can just accept arbitrary UI. And then, of course, on the call side, we get this really nice trailing lambda syntax where we can contain the UI in our original component. So for example, we could pass in a row here and an icon and a text next to each other, and then that would show up on the button. We can go further with using slots by adding a scope to the slot. So For example, in the case of our button, if we know that in most cases, users will want to lay out multiple components next to each other when they are calling our component, we don't have to force them to create that row. We can create that row in the implementation of the button and then put the composable function into a row scope. That way the callers see that whatever content they're emitting in the function that they've passed in will end up inside a row layout side by side. This also gives us access to things that only exist in rows. So for example, you cannot use this weight modifier in arbitrary places in Compose code. This is only available when you are inside a row, because it's the row layout that will interpret these weights and use it to size the contents that are inside it. So this is also something really nice we can provide here. Now, you might be wondering, isn't this now a component here which emits multiple nodes, which we said we shouldn't do? We said we should always have a single root for every composable component. And the short answer is that it isn't. So this here is not really a component, this function that we have done here. It's just a function that we're creating as a lambda, so it's a single-use function. We already see that we're inside a row scope, so we know exactly that the nodes that we emit are going to be put into a layout correctly. And we're not going to call this from anywhere else because it's not like a top-level function. Something interesting to think about when you're building APIs that accept UI as parameters is the lifecycle of those slots. So here we have, again, an example where we have some kind of condition in the component, and depending on that condition, we either have a row or a column layout. And whichever layout we're using, in both of those, we use the content parameter that we've received, which is slot. And the problem with this code here is that as time goes on, the preference item is created at some point, and it exists for some amount of time. But the content, which is also created at the same time in like one of the layouts, will actually be dropped and then re-executed and added to the composition again anytime that the state changes here. So as we're going from one of the conditional branches to the other one, the existing content that we've produced by calling the parameter of the function, the content function here, that content gets dropped, and we have to call that function again so that it produces UI again, and we can reattach it to the new layout that we've created. So the guidelines say that whenever possible, your slots lifecycles should match the lifecycles of their hosting components. So essentially here, we would want content to continuously exist and just be moved between different places, between the row and the column, but not be recreated every time. And the solution to this is a very, very specific Compose API, which is designed for exactly this use case. So the API is called movable content off. You can wrap a composable function with movable content off. Then you can remember that at some point in your composition. And this gives you a new composable function to call, which, well, moves content, as it's called, multiple times. So as the state changes between checked being true or false, whenever movable content is invoked, it will produce the UI if it doesn't exist yet, or if it has already been produced, it will just move those nodes to another place in the compose tree, which is really convenient. I, again, don't want to dive into the details of this, but there's an excellent blog post about exploring movable content off and movable content with receiver off, which you can check out, again, on that link. All right, with that, I want to wrap up the parameters part of the talk. And so the last thing we'll look at here is how to order our parameters. So here's the recommended ordering for parameters in Compose. Required parameters should go first. Then we can have our optional parameters, with modifier being the first one. And finally, we should have primary slot if we accept a slot parameter and we have a primary one, if in case there's multiple. Then that should be called content, and it should be at the end of the parameter list. To take a look at these rules, I've grabbed this random function from some open source project, and we'll see how it doesn't comply with these rules and fix it up a bit. So first, we should have our required parameters. Why is this a good idea? Because if required parameters are first, then the component is callable by just providing those required parameters, and we don't have to do name parameters or anything like that. We can just pass in the required parameters, and the component will already have a basic like working copy. For example, again, in the case of the text function, which is also being called here, that only has a single required parameter, so you can pass in just a single string and already have it working. In this case, this would not work because the first parameter is a modifier. We couldn't just skip that parameter because we're providing things positionally. So to fix that, we would have to move these things to the top of the parameter list. We could, of course, always name these parameters, especially since we have a Boolean here, which just says true on its own, which is really not helpful. It's always a good idea to name these parameters. But maybe you have inline hints in your IDE, and then you don't need them so much. Then we should have optional parameters next. So we have the basic required parameters, and then optional parameters allow us to further customize the behavior if we start providing them. And again, the rule here is that the first one of these should be the modifier. The reason why this is important is because if we all adhere to this convention and we all use modifier as the first optional parameter, then if you take a look at any composable function call, which already has its required parameters, you can, without thinking, just add a modifier for the next parameter, and it should just work. So in this case, for example, we could just grab a modifier, put it on the next parameter slot, and if we follow these guidelines, then that will just work because that's the next parameter. Finally, we should have the trailing lambda if we do have it, and in this case we do have it. Of course, this allows the nice like visual containment syntax, this like DSL-like syntax in Kotlin, which allows us to have the last lambda parameter outside of the parameter list. And the only problem here is the naming of the parameter. So by convention, this should be called content. So we can just fix this. A very quick note, which I didn't add the slide for, but within each of these categories, you might have a lot of different parameters. You might have, like 10, 15 optional parameters, for example. So within those categories, you should also strive to put the more important parameters first so that they're more discoverable, just as a general rule of thumb. Next up, let's talk a bit about state handling. And I want to start this section by talking about the state type specifically. So the question I want to answer first is it a good idea to pass in mutable state into a component? It's state, we're passing it in as a parameter, it kind of makes sense. This is something you should definitely not be doing. This again introduces an ownership problem for this state. So this state has been created outside of the component, so someone already owns and manages this state. But if we pass it in as mutable state to the component, then suddenly the component can change its own state without us being able to control it from the outside. So you should avoid passing in mutable state, and it's a lot better, it's a much nicer idea to pass in just plain values instead, and then have the component use a callback to indicate to the caller that it wishes to change the state. So you might be wondering, is it okay if we use the read-only state then? Because then we don't have the ownership problem because the component cannot change it. We can still have a callback where it can indicate that it wants to change the state. And the answer is that this is safe to do, but you should still avoid it. The problem with this one is that it's a very specific type of parameter. So it forces callers to always provide a state object specifically. But what if on the call side they already have a plain value from somewhere? What if they already have a float and you're requiring them to pass in a state of float? Then you're forcing them to create a new state object just to put the float in there. And then inside your component, you're probably going to read the float from that state object. So we've just packaged it and unpackaged it for no reason. So in general, you should prefer accepting plain parameters like these as parameters to your components. And in some cases, you can also accept a function which will produce the value that you need. This gives a lot of flexibility on the call side because if you're accepting a function, then that could be a constant, it can be an existing plain value, it could read existing composable state, or it could read values from some state object, which isn't just the state type, but some other like state holder in Compose, which is backed by a composable state. So this gives a lot of flexibility, and what it also offers the implementation of the component is to defer the read of this state. So you don't have to read this immediately as you've received it, but you might be able to read it in like a later stage of composition or something like that, which is great for optimizing things. Here, again, I have an article to recommend, which talks about debugging recomposition. And as a part of that, talks about how you can defer reads to state objects and optimize a lot of things that way in Compose. The final thing I want to touch on is state holders. So as you're adding your parameters to your components, you might end up in a situation where you have a lot of state going in and a lot of callbacks coming out so that the component can request updates to the state. I'm just going to do this with 2 different pieces of state, but you can imagine this scaling upwards. So at some point, you might decide that you don't want to have all of these split components, which is just a lot of parameters to provide. You don't want to have all of these components in your component, all of these parameters in your component's parameter list. And so in these cases, you can extract this into a state holder. For example, this one, and then instead of providing all of those individual parameters, you can provide just a single one. Now, there is a convention for this. The state holder should have the name of the component plus the state suffix, and it should be stable. Stable here means that whenever the values inside the state holder change, it should notify the composition. So this essentially means that the implementation should be based on Compose mutable state. But I will, again, not dive too deeply into stability, but you can learn more about it on that link. Speaking of the implementation, there should be an implementation of this state, which is quite important, because if you require an interface as a parameter and your callers have to implement that every time that they want to use the component, that's really inconvenient. So you better provide an implementation that they can use. So here's a very simple implementation of this one, where we are just delegating both of the properties into mutable state of, to make sure that we're complying with the stability requirement. After this, to make the API even nicer, what we can do is we can make the implementation class private detail. So we can make that class private, and we can have a factory function that can produce instances of this, but only returning the interface type. Here, because this is not a composable function, it doesn't depend on anything in the composition, this can actually use the regular, like a Kotlin, like virtual constructor or factory function or whatever you want to call this, where the name matches the name of the type that's returned. And then to go even further so that we are not forcing our clients to even call this function every time, if they don't want to manage the state, we can have a default value where remember can help us. And if there's no state provided, we can create our own state object, remember it by default, and then work with that state. But of course, one can always be passed in. Now, all of this code maybe doesn't seem like the solution to the problem of having 4 parameters. This is way more code than what we started with. But if you're designing a library, then this is the nice way of going about it, of creating an interface, providing a default implementation. Then clients can always provide their own implementation if they need even further customization. And again, there's a lot about this in the guidelines still. But what I really want to highlight at this point, after Ben's done taking the picture, thank you, is that for app development, where you don't need all of this flexibility and you're fine with just a single implementation, you don't have to build up all of these things. So if you're just working in an app and you want to introduce a state holder, you can just have that be a class like this. It doesn't have to be an interface and all that, as long as it's, again, stable. And then, of course, as you're later on editing your code and maybe find yourself needing multiple implementations for the same state holder, you can always just extract an interface out of this. And of course, there's someone providing tools for that as well. In conclusion, I really want to emphasize that you don't have to really strictly follow all of these rules, especially if you're on the app side of things. You can be a lot more flexible about it, but if you're building libraries, internal or external, or like something really core that a lot of others are going to use, then please take a good look at these guidelines and try to follow them so that we can all have a nice time in Compose and have common understanding and expectations of how these components should work. And I also don't expect you to remember all of these things after the talk. So again, the guideline docs are always there. You can reference them if you have a specific design problem. But if you took a couple ideas away from this talk, then I'm already happy with that. So here are the links that I've promised you. during the talk. You can check out all of those things to learn more about them. You can also find these and the slides on the link on the slide. And you can find me on social media like Mastodon and also around the conference. So please come ask questions about composing APIs. I hope everyone got that pun before choosing this talk, by the way. So ask questions about that, Compose Multiplatform, Kotlin Multiplatform, anything like that. I'm really happy to chat about. And I think that's it.
Thank you, Marton.